Hi everybody, this is Dr. Shrikant. I was an intern at Sparks Foundation in Data Science and Business Analytics. This is my second task which I am going to explaining here. The task is prediction using unsupervised machine learning. I was completed my first task successfully and it has been posted in LinkedIn, GitHub and YouTube as well. Before explaining to the second task, I would like to throw some light on machine learning. There are three different types in the machine learning. One, supervised machine learning, unsupervised machine learning, and reinforcement machine learning. The first task is based on unsupervised machine learning, where the linear regression model will be used to process the data. In supervised machine learning, the algorithm has been built and trained, and that will be used to predict and evaluate the data. After prediction, the absolute error will be calculated. That is the difference between the predicted and actual values. Further, correlation coefficient also calculated to know the relationship between the two dependent variables. That is percentage of score and the number of hours studied. This is all about supervised machine learning. In supervised machine learning, the data will be split into 80% and 20%. 80% of the data will be used to train the algorithm and 20% of the data will be used to test the algorithm. Whereas in unsupervised machine learning, we will be using unlabeled data, untagged data, and there is no responses are provided. And here in unsupervised machine learning, we are going to extract the hidden patterns of the data to derive insights which help us to develop our business. In this unsupervised machine learning task, here we are going to predict the number of clusters by using elbow diagram. Let's see the object of the study to find out the optimum number of clusters for k means and to determine the value of k. K is equal to 3 means there are 3 clusters in the data. The K means clustering will be used in the unsupervised machine learning. Clustering means each cluster is having a centroid where all the data points are grouped together. In each group, similar or identical data points will be placed, and different data points will be placed in different groups. This is all about clustering analysis. K means clustering analysis will be used in the unsupervised machine learning to process the data, and elbow diagram or elbow plot will be used to predict the number of clusters which is going to expected from the data. The source of the data will be retrieved by the link provided here, and the major steps involved. We need to define the problem. In this task, we are going to predict the number of clusters using elbow diagram. After identifying the number of clusters, the clusters will be visualized, and there are number of libraries are required to perform this task, and those libraries are imported into this Jupyter notebook, and the versions of those libraries also have been checked. And importing libraries or required libraries have been imported, and importing data site by using the provided URL. The data has been retrieved into this notebook, and the clustering analysis has been done. The summarizing of the data, how the data will be, like the shape of the data and the top 5 values and bottom 5 values, and how the data will be distributed. And data verification for null values. Is there any null values in the data? Means missing values that has been evaluated before processing the data. And statistical summary. Statistical summary in the sense where we are going to measure mean and mode, median of the data. And the next step is plotting elbow plot, and this is very crucial. This is what we are performing the second task. Based on this, we are going to determine the number of clusters expected from the data and the visualization of clusters. Then we need to visualize how the clusters have been separated. In the clustering, what will happen? The identical values are grouped together in a single cluster where the centroid point at the middle and the different data points are separated in the different groups. This is what clustering. In this task, we are using k-means clustering to process the data to measure or identify the number of clusters which are expected from the data. That's what we are using elbow plot. And finally, the conclusion has been made. In this task, the data is given. Totally, there are 150 values. Means 150 rows will be there, and 4 parameters, attributable parameters are there. That petal length and petal width, sepal length and sepal width, and 3 species are there. By using k-means clustering, what we are going to do here, we need to separate these parameters, means 4 attributes of 150 data points has been clustered based on the species. So this is what we are going to do in the second task. Next, how the algorithm is worked. Because in supervised machine learning, we need to build an algorithm that has been used to, segregate the data points based on the identity. There are different steps involved in the k-means algorithm, means how it will work. The first step is we need to select how many number of clusters we are expecting from the data point. That is called as k-means value. In this task, we are predicting that 3 groups are expected, and select the random k points or centroid. So we need to identify the center point of the data points. From the data point, we need to calculate Euclidean distance to the each and every data point in the data set. So based on that, we need to calculate mean and median, and some statistical task has to be done. Then based on that, the distance of the data point has been shifted, and it is going to form a new cluster and new centroid. Okay, likewise, we need to repeat the same process until there is no shift in the centroid. Let's discuss how the k-means algorithm will work. And first of all, we need to select the k value. That is, we expected that 3 clusters we are expecting from the data, and select the random k points or centroids, and assign each data point to their closest centroid, which will form the predicted predefined cluster, k clusters. Calculate the variance and place a new centroid of each clusters. Already I was told that the variance has been calculated, means there is a shift in the centroid point, because we are calculating Euclidean distance from the each data point. Then it will shift toward the nearest data point. So there is a variation in between the old and new data point. That is called as variance. That has been calculated. Calculate the variance and place a new centroid of each cluster. Repeat that third step means assign each data point to the closest centroid. Again, we need to assign each data point because the distance has been calculated. And if any reassignment occurs, then go to 4 steps and go to finish. Then again, what we have to do, so the process of formation of new centroid is called as iterations. As the number of iterations has been increased, there is a shift in the centroid and formation of new centroid, and the process will be stopped. There is no more formation of new centroid, and the data points are very close to each other in a single group. Okay, so this is called as the working of k-means algorithm. Then the model is ready. Okay, first we need to predict the number of clusters. Then we need to assign the centroid. Then from the centroid we need to calculate the Euclidean distance to each data point in the group or different groups. Okay, so after calculating, there is a shift in the centroid, and which is going to form a new centroid. Again, from new centroid we need to calculate the Euclidean distance to the each and every data point in the group, and also in between different groups. Then it is going to form a new centroid. Likewise, the process is called as iterations. As the number of iterations has been increased, it is going to form a new centroid. So finally, there is a finish has been observed, where there is no shift in the data point because all the data points are very close together and forms a cluster. So this is called as formation of k-means algorithm. Next, definition of defining the problem. Problem statement is what will be the optimum number of clusters for k-means and their visualization. Next is check off versions of the library, because here we will be using number of libraries to perform this task, and the versions of these libraries has been verified by format. Here numpy we have imported, and the version has been checked, and matplotlib and pandas, sklearn and seaborn, these things will be used, and the versions of these libraries have been verified. And sklearn is one of the most important packages in machine learning, and it provides the maximum number of functions and algorithms. To use k-means clustering, we need to call it from sklearn package. Importing libraries, these are the libraries which has to be imported into the Jupyter notebook to perform this unsupervised machine learning. NumPy as NP, Matplotlib as PLT, pandas, sklearn cluster, import k-means. Here this is very important, k-means, and sklearn import datasets and empirical toolkits. Mplot 3D, access 3D, you need to visualize the data in 3D. So this is the library is very important to import, and we need to see the relationship between the data points, whether it is following the normal distribution or which kind of distribution that will be evaluated by using or by importing this sklearn mixture, import Gaussian mixture, Matplotlib and pandas, and to avoid any warnings, the import warnings, and cbanan SNS. All these libraries are imported. Libraries are imported successfully, and importing dataset. Iris dataset. Already I told that there are 150 points, 150 rows in the datasets, and 4 major columns which represents cephal length and cephal width and petal length and petal width. By using this k-means clustering, we need to separate all these data points pertaining to the width and length of the with respect to species. The data will be loaded into the Jupyter notebook, data imported successfully, and here we need to form a bunch of objects by means of numpy. Bunch of objects are just a way to package some numpy arrays. So here there is a formation of numpy array which represents all the data points in the data set in an array form. This is a two-dimensional array or a two-dimensional matrix. See, all the data points are placed in array. Two-dimensional matrix or two-dimensional array. And see, totally there is a 150 rows and 4 columns. These 4 columns means there is a cephal length and cephal width, petal length and petal width. So all these data points are captured in a two-dimensional matrix or two-dimensional array using NumPy. Two-dimensional numerical array or matrix called the futures matrix with a shape. Then print iris future names. Future means whatever the all columns in the data set. Print the names of the 4 futures. The futures are cephal length, cephal width, petal length and petal width. So if you type, the code is iris.future names, so it is going to present cephal length, cephal width and petal length and petal width. In machine learning, futures means we need to remember that all the columns are represented as futures, all the rows are represented as observations. So by means this code here just we are returning the information. Print iris target. Here target means each observations means rows. So that will be written in single dimensional, one dimensional array of NumPy array. Next, print iris target means so the species are the targets. Here 0 represents setosa, 1 represents versicolor and 2 represents virginica. So if give the code iris.target names, it is going to return setosa, versicolor and virginica. And if it is futures means cephal length, cephal width and petal length and petal width. And all the data is structured in two-dimensional NumPy array, and all the futures are structured in a one-dimensional featured array. And the requirements working with the scikit-learn, because futures and responses are the separate objects, and futures means all the columns and responses are observations are the rows. Futures and responses should be numeric, and there are numeric, and futures and responses should be NumPy arrays. We converted into two-dimensional array, and one is one-dimensional array. We have converted it by using NumPy. Futures and responses should have specific shapes. It has got some shape. The type of the targets, that is strings, and the data shape 150 columns 150 rows and 4 columns. And iris target shape. So how many? There are 150, and futures, all the futures, that is 150 rows and 4 columns, and targets shape means 150, like 150 data points are there, and all futures futures all append observation 0, 1, 2, 3, all the observations, because there are 4 observations are there. That is cephal length, cephal width, petal length and petal width. So all the features are got printed. Every observation get appended into the list once it is read. For loop is used for iteration process. So next, slicing of the data means like slicing and dicing can be done, and ilog function, using ilog function here. This will give this is the output, and cephal length 150 points are there. The data type is float. I lock 0. 0 means the first row has been printed here, and sepal length, width, and petal length and petal width, and all the data points has been retrieved here. 150 rows and 4 columns by using the iloc function 0 to 4. Summarizing the data set, that is shape of the data set, and 150 and 4, 150 rows and 4 columns, and first 5 data points has been written by this df dot head, and it is df dot tile. It is going to give last 5 rows, that is 145 to 195 values has been written by using this code df dot tile. Then information on the data, df dot info, it is going to give the information about the data and how many sepal length values, width values, and length, petal length and petal width values. That is, no null values are there. The data type is float, and there are 150 number is there. The memory usage in the RAM 4.8 KB. Next, df dot describe. Here it is going to give the statistical summary of the data, that is the count. There are 150 values are there. Mean of the cepal length, that is 5.8, and cepal width 3.05, and petal length 3.75, and petal width 1.19. and standard deviation and minimum value. What is the minimum value in the cepal length, and what will be the minimum value in the cepal width, and what will be the minimum value in the petal length, and what will be the minimum value in the petal width, and what is the maximum value in the cepal length, cepal width, petal length, and petal width. And also at 25% means the quarter value, and mid value, and third quarter value 75%. So all this represents statistical distribution of the data. And for the verification of null values in the data set, and this plot is going to represent. So here everything is clear. There is no null values is present. Cepal length, cepal width, and petal length and petal width. And uniformity of the data also represented by using a SNS Seaborn heat map, uniform data. So data will be uniform. You can see here normal data, here we need to create a random sequence by NumPy array. So here from the data points 150 rows are there, 4 columns are there, just we need only 102 data points, that is columns. By this we can get random code having 100 points, and they are into array of shape of 102. We check it by using this command, this iris shape. This is going to give the shape of the data 102, and the expected or predicted clusters will be 3. This number is given arbitrarily by us because there is no thumb rule in assigning the cluster values. So you can predict yourself how many you are going to expected from the data set. Here we predicted that 3 clusters going to form, which we can choose any number to define the number of clusters. This is prediction. K means here we are predicting, we are training the algorithm, that is n clusters, n 3 clusters. So we can see our 3 clusters by using the following command. So these are the 3 clusters, the array, that 2-dimensional array, 3 data points are 3 clusters. To check the labels created, we can use the following command. It gives the labels created for our data. So whatever the labels means observations. So these are the observations in a 2-dimensional array. Next, plotting of K means 3D plot, and the 3D plot has been plotted. So this is the K means 3D plot. Here there is a formation of clusters, 3 different clusters, one blue color and a yellow color is there, purple color is there, and petal width and sepal length and petal length. We can see that the data points in the boundary of the purple and yellow clusters can be either one. So there is some little bit mix up of the data points yellow and purple. So in order to get good separation, some different approach is necessary. By using this 3D diagram, you can visualize how the data points are interacting with each other. So we can say that the yellow and the purple data point has been very close to each other at boundary point. So this can be also visualized by this can be also visualized by Gaussian mixture model, and in this case the plot has been plotted, and this is the Gaussian mixture model. So above Gaussian mixture model, the colors of the data points are based on Gaussian probability of being near the cluster. The red and green blue values are based on the nearness of the red, blue, green clusters. If you look at data points near the boundary at blue and red cluster, you shall see purple indicating the data points are very close to either clusters. So this is the Gaussian distribution, how the data points are get separated. In this case also we can see there is a mix up of data points at the boundary. Here we can see in this area. So this is the boundary. There is a mixes of data points. In the same also predicted by using this k-means 3D plot. Here also there is a mix up of the data at boundary point. Here purple and yellow points. Some points are mixed together. Box plot and how the data points will be interacted or get separated, that is visualized by box plot. Here we are taking first 5 values. So here these are the box plots of the sepal length, sepal width, petal length and petal width, and this represent the middle value, and this represent the max value, and this is the low or minimum value. So likewise the data points will be visualized by box plot to extract some insights from the data. And this is the plot of individual plots of sepal length, sepal width and sepal length, petal length and petal width. And these are the histograms, represent 4 parameters or 4 features of the data. And scattered matrix, and here this is the plotting of scattered plot in between features and targets. Targets are observations, features means whatever the columns means 4 columns of this data, that is sepal length, sepal width, petal length and petal width. Then the relation between the sepal length and sepal width has been plotted here by using so this is the relation, means here the blue data points are very well separated. Only the thing is these 2 points, red and green data points get mixed up. This has to be separated. In the 3D diagram also we came to know that there is a mix up of data points at the boundary point. Here in this case also we are establishing the relationship between the sepal length and sepal width, and there will be a mix up of points we can see here. And relationship between the petal length and petal width, here also there is a mix up of data points. Next, elbow method to predict the number of clusters which are going to form. Here see the elbow method. Here there is a depression in the curve, it is going to become plateau, and here this is the point which represent the maximum number of clusters we are expecting from the data set, and this is exactly 3, 2, 3, 4, 5, 6, like that. This is the 3 is the maximum, 3 or 4 data clusters we are going to expecting. This is what the code explanation here. It is plotted in between WHCC, means that is mean we calculated in between the data points of the group and number of clusters. Here the plot is plotted, that is called as elbow plot, where we are going to predict the number of clusters. It is the number of clusters is 3. Then visualization of clusters. Here the maximum iterations are 300. Iterations means that is a creation of new centroid by calculating the distance in between the centroid to different data points in the different clusters. As the maximum number of iterations are increased, there is a formation of new clusters. At a moment or at a point, there is no formation of new cluster. It indicates the maximum number of, or the maximum separation can be taken place. Visualization of clusters. Here, this is the visualization of clusters. One cluster. This is the centroid, and this is also centroid, and this is also yellow. One is centroid. And red one represent the setosa, and blue one represent the versicolor, and this is the green color versinica. Conclusion, we have successfully created 3 clusters from our data point. All the clusters are shown different colors, so the k value is 3.